Thank you, Judy. Yeah, I'm John Clingan Smith. I'm a PhD candidate, computer science department within the School of Informatics and Computing here at IU. I'll spend some time today talking about virtual clusters. We'll kind of recap again what exactly is MapReduce. You'll probably be fully aware of MapReduce by the end of the day with several other sessions here and the technologies that can sit on top of that. So we've got a full afternoon ahead of you here in this space. So we'll talk a little bit here about virtual clusters. I know Tom Hacker yesterday from Purdue talked a little bit about virtual clusters in high-performance computing. I'll relate that a little bit to performing MapReduce within clusters. Also, from my background, I know there's probably varying backgrounds across the universities, across the room here at IU. I got into this space actually kind of through machine learning, artificial intelligence, and also kind of database systems. I started looking at, when my data got large enough, what kind of environments out there can I actually do my research on top of, which got me a little bit lower into systems-related stuff with building virtual clusters. And so now I've kind of gone down and come back up. And so for researchers out there that say, wait, I'm not a computer scientist, I'm more interested in bioinformatics, I'm more interested in linguistics, running applications on there. There are several questions about how do I know how many mappers I should be using? I mean, these are interesting problems to run on these frameworks, right, in your particular space. And so we can talk a little bit about that. So I'm not going to go too deep into the nuts and bolts of building clusters, but let's talk about what we want to do in running things on top of them. So I'm going to split my title up into different pieces here, right? We'll talk about what exactly is a virtual cluster, we'll talk about MapReduce, and we'll talk about the cloud. And I know you'll probably see these topics across the variety of other presentations through the several days session here in the summer school. So let's start with MapReduce. I know you'll probably see examples. You saw one in the last presentation. You'll probably see more to come as the day goes on. This is just some simple Python code that can take you through, because actually in base Python you can do MapReduce without even having to have a cluster. So I thought I'd take you through a simple example of running that, right? So I've got here a simple line that says hello world, goodbye world, right? And so the first thing I'm going to do is I'm going to split that line into words, right? So I just split it by the spaces, and you can see the list that I have there, right? I've got obviously 4 elements in my list. I've got a couple worlds, right? And I've got hello and goodbye. So this concept of MapReduce comes from the functional programming paradigm of I've got something called map, and actually in Python there is this keyword called map. So you're actually seeing here from a very simple example of how I'm taking 4 words, right, and I'm using this map tool to say for each X in my words, map that to this kind of key value pair of word and this 1. So you're getting this kind of tuple out of this, right? So real simple that I've obviously gone through a map step now to get a list of tuples with these values. So obviously I can't do MapReduce without reduce. So let's go from my map example now into actually reducing that. So the first thing I'm going to do is I'm going to sort my list. So I've obviously got now my worlds together, and my goodbye and hello are preceding that. So now I'll actually go through and I'll iterate these, and this little group by function that's within Python as well allows me to take this list of items, kind of start to say group by this keyword, this first key that I have in that, and then perform a reduce step. And so this reduce step saying, oops, sorry about that, this reduce step saying take an X and a Y and add them together for each time I see that 1, right? And so obviously then at the very end of that statement, all I'm going to do then is print out, my keys plus my values. So we saw previously, right, in the first hour of kind of MapReduce from a higher level framework, right? Here's a very simple, like, you could obviously copy my code from this presentation. It's available online. Put it into a Python script and run this example, and you would get actually MapReduce from a very simple example, right? So hopefully that's getting you, kind of right into the nitty-gritty of what exactly is MapReduce, right? I got this map thing, and I'm taking some keys. I'm going to put a value associated with it, right? And now I'm going to kind of group them all together and reduce that into what's my final output. And so this hello world example, I think will kind of, it's kind of the classic, word count's kind of the classic MapReduce example that people use. You'll find plenty of examples if you want to search online or doing WordCap with MapReduce, and that at least get you started with understanding this paradigm and then get you further into large-scale MapReduce applications. So again, what did we just do? We took a line, we split it, right? So we split our data off into words. We mapped that into, these kind of key value pairs. We sorted it so that our keys are in order, right? And this is in that kind of short sort shuffle step that we saw previously. And then we reduced it into a final output, right? So this kind of split, map, short, shuffle, and reduce is kind of the high-level paradigm for no matter if you're in a cluster, no matter if you're running on your machine, which we'll get to a little bit later when we talk about VirtualBox. But this is your very high-level way to kind of get into this programming paradigm, right? And so again, the value of knowing what your keys are. So in this case, we kind of said the keys are these words that we're dealing with here. And so you create this kind of key value pair, you sort by the key, right? And then you reduce the operation so that your value then at the very end of it is the item that's actually changing for you. So we saw a very similar diagram in the previous presentation, but again, now let's take a high level of this. We take some input data, we split it, we perform our map operation on each one of those individual items. We then do some sort of a short sort shuffle step, and then we reduce it to get some output data, right? So very simple. Now we've taken this concrete example, now mapped it back up to this high level diagram of what exactly we're doing.